Mathematics, love it, live it. You are welcome back again to our math session, and today we are continuing with linear programming. Have a look at the applications of linear programming in our day-to-day lives. Now here we go. We have Mukasa plans to use 4,000 shillings to buy graph books and blacker books. He has to buy more than one graph book and not greater than 4 black books. One graph book costs 12,000 shillings, while one black book costs 3,000 shillings. Find the least and the maximum amount he can use. Let X and Y be the number of black and graph books respectively. So now when we have that, there is what we call facts analysis. We have to analyze the facts given to us. Now the facts given to us have to be got from that situation of which we can refer to as a scenario. Therefore, what we have to do is remember that the other time we had to look at how we could translate English expressions into mathematical inequality signs. Then after that, we move through from inequality to graphing. Then from graphing to integral values. Then from integral values to the solutions. Therefore, here this is what we are going to do. Let us analyze the facts by getting out the inequalities. Now the inequalities over there, one you can be told that look for the inequalities or write the inequalities, but here it has been embedded in it, has been put in it, it has been hidden in it. Therefore, what we have to do first of all is to look for the inequalities. Now, how are we going to look for the inequalities? One, when one has some amount he has to spend, the intention is either to spend the amount which is equal to what he has earmarked, or what he has planned, or what he has, or to spend less than that planned amount. Therefore, let us have a look at the planned amount costs. So here we have the costs. We've been told that let X be the number of blacker books and then Y be the number of graph books. Therefore, if we buy one blacker book, that means that he has to pay only 3,000 shillings. If we buy 2 graph books, it has to be 2 times the cost per graph book. But now here we have X blacker books and then Y graph books. But then the cost per blacker book is 3,000. So we are going to say 3,000 X. Why are we saying 3,000 X? Because X is the number of blacker books, and then the 3,000 is the cost per blacker book. Therefore, the amount to spend on all of blacker books is going to be the number of blacker books times the cost per blacker book. The number of blacker book here is X, then the cost per blacker book is 3,000. Therefore, we have 3,000 times X. Therefore, we get 3,000 X. But is that the very person who is also going to buy the graph books? Therefore, plus. Now, what's the cost per graph book? It is 2,000. 2,000. Then 2,000 times the number of graph books, that's Y. But then he has planned to use only 12,000 shillings. Therefore, his intention is either to use the whole lot of it or just less than that. Therefore, we have less than or equal to 12,000 shillings. Now, the first inequality we have is 3000x plus 2000y is less than or equal to 12,000. But the other time we looked at how can we simplify. You can write an inequality and as well as simplify. Now when we simplify this inequality, I hope 3 zeros are everywhere. Therefore we can divide by 3 zeros, divide by 1,000, by 1,000, by 1,000. Now what do we have? This is the 1,000. What do we have? This is 3 goes with that. Wow. These ones go with that. Wow. Then these ones also go with that. Now what do we have? We have 3x, it's okay, plus 2y is less than or equal to 12. Therefore that is our inequality 1. Inequality 1. How have we got it from? Where have we got it from? From the costs. Then 2. We are being told that he has to buy more than one graph book. More than one graph book. Now when it comes to more than one graph book, what does that mean? That means, it means that more than, we have to use a sign greater than. And what is a graph book being represented with? It's being represented by y. Therefore the second inequality is y is greater than 1. That is the second inequality. The second inequality. And then here we have, and not greater than 4 black books. Not greater than 4 black books. Not greater than 4. We said, when we translate that one, not greater than 4, it means that less than or equal to 4. Therefore, we are going to say x is less than or equal to 4. That is equation 3. But never forget, the other time we said that there are some situations when the students do fail to get all the required inequalities. We have obvious inequalities. Obvious inequalities are 2, because we are told that he has to buy graph books and then black books. Therefore, that means that black books and black books and graph books have to exist. Therefore, other inequalities we have x is greater than 0, that is 4, and then y is greater than 0, that is the 15th equation. Though these ones are obvious, there you may find that there is no need of shading these ones, but where the need arises, we can also say them. Then, having got this information, we've got this, but we've been told that to find the least and the maximum amount you can use. Therefore, the least and the maximum amount we can use, that is the objective function we have to look for. We said that within the objective function, we have the maxima and then the minima. When it comes to the minimum, we are looking for the maxima, and we are looking for the minima. When it comes to the maximum, we are looking for the maxima. Therefore, what we have to do is 1. Having got this, now we go to our summarized table. This is our summarized information. Within the summarized information, to cut it short, what we do, we look for the inequality. This is the inequality, right? Then after the inequality, we go to the boundary line. Then after the boundary line, we have a look at the nature of the boundary line. Here we put the nature. After the nature, then we come to either we look for the parts or the points. We said the other time that if we have x and y, we look for the cuts. If we have either x or y only, we look for the points. So here we have the cuts or points. Cuts or points. Now look here. What is the first inequality are we having? We are having 3x plus 2y less than or equal to 12. Less than or equal to 12. When it comes to the boundary line we say that all these signs, either this sign or this one or and this one, they have to be replaced with equal signs. Therefore, we are going to say 3x plus 2y equals to 12. 3x plus 2y equals to 12. Now, when it comes to the nature of the boundary line, the nature of the boundary line is determined by the inequality, determined by the mathematical inequality sign. Here, it is less than or equal. Therefore, that's an implication that it is solid, right? That is solid. Now, if it is solid, now we have to look for the cards. When you are looking for the cards, what we do? We use this one. That 3x plus 2y equals to 12. Now, that's our source. When x is 0. When x is 0. When x is 0. When x is 0, we put here 0. Therefore, we shall have 3 times 0, that is 0. Then plus 2y equals to 12. Therefore, if this is 0, then we shall have that 2y equals to 12. Now, if 2y equals to 12, then that means that our y is going to be 6. Therefore, the first part is 0.6. For those ones who may have any trouble with this, you have to revisit. You have to revisit the video we had the other time recently. It's on the channel. Then 2, when y is 0. When y is 0. When y is 0, we shall put here 0. So we shall have this. When y is 0. When y is 0, here we shall have 2 times 0, which is 0. Therefore, we shall have 3x equals to 12. And if 3x equals 4, that's an indication that x equals 4. X equals 4. Therefore, we have the first part as 0.6, and then the second one is 4.0. Right. That's that. We proceed. We come to this one. Y is greater than 1. Y is greater than 1. Y is greater than 1. What we have to do here is look for the boundary line. The boundary line is going to be y equals 1. Now, if y equals 1, what do we do next? We have to look at the nature of the boundary line. This is sign. When we have this one, it means that the line we have to use is broken. Take note of that. So here we have a broken line. We have a broken line. But remember, here we are being told that y equals to 1. Therefore, give or get out any coordinates, so long as y is 1. Therefore, we can have 0, 1. Right? Even the one we are thinking about, let me write it. We can have 2y. That's okay. Next, we can have 4, 1. Wow. That's fine. Let's go. Proceed. Now we have this one, which is telling us x is less than or equal to 4. X is less than or equal to 4. X is less than or equal to 4. It means that the boundary line has to be replaced with the equal signs. Either with this sign or this sign or that sign, whatever sign is there. When it comes to the boundary line, has to be replaced with equal signs. Good. So here we are having x equals 4. Now, when x equals 4, remember that here we have an equal sign embedded in this. They are combined. Therefore, the line here has to be solid. This is a solid line. That's a solid line. Therefore, here we are saying that x equals 4. Now, this is a ruling. This ruling almost just helps us to tell that instead any coordinates, so long as x is 4. Therefore, we can have 4, 1. Right? Can have 4, 2. Right? Can have 4, 3. Then for these ones, there is no need of that. We shall have a look at when can we shade them, when and we shade them. Therefore, the major inequalities we have, there are three. We had this one, we had this one, we had this one. Therefore, next, what are we going to do? We are going to transfer this information onto our graph. But remember, in this world, never be hesitant to begin up with the materials you have. You begin up with the materials you have, and then better equipment can find you on the way. Therefore, now, here we are. Right. We have this. That's my graph. That is my graph. Now, if that's my graph, what are we going to do? We are going to proceed. Remember that we began from here, this one, this one, this one. When it comes to graphing, we are beginning from this one to this, to this, to this. I equated with that one to climbing up a tree. You climb from downwards, upwards. When you are fed up of being up, you begin from where you ended to come down. So we are beginning from here. The first one, we draw our graph. When we draw our graph, this is 0, 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Remember, this is x-axis. What is x-axis standing for? X-axis is standing for the number of black books. Then here we have the y. What's y standing for? The number of graph books. This is the number of black books, number of graph books. Then here we have 6. This is 5. That is 5. Then here we have 6. This is 5. Here we have 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6. Then here we have 0, 6, 0, 6. When it's 0, it is 6. It's here. It's there. Right? When it is 4, it is 0. When it's 4, it's 0. It's here. Now those are the cuts. On the first line, which type of line is that one? It's the line which is solid. So we join using a solid line. Solid line, this is what we mean by solid line. Solid line, this is what we mean. We have this. That is the solid line. Now the solid line, the name of the solid line is this one. We have 3x plus 2y equals to 12. 3x plus y equals to 12. But then remember, we need to get the region which satisfies with this. But the other time we say that if at all we are lucky, that point 0, 0 lies on one of the sides. Now when we have this line divides the graph into two parts. The part above and the part below. And the part below that is point 0, 0. Therefore it is wise to use point 0, 0 as a test point. Now when we use point 0, 0, here we shall have 0, 0. What are we having? We are having 3x plus 2y less than 12. Less than or equal to 12. If we put here 0, it's going to be 0. Plus 0. Is 0 plus 0 less than 12? Automatically the answer is yes. But the moment we get the region which has yes as an answer, we say that that's the wanted region. And the wanted region, it's not advisable to shade it because further on there are some characteristics we need to analyze from that region. Hence, we shade that unwanted region. Therefore, this region is saying yes. Therefore, the other region is the stubborn region. If you have two children, one of them is always saying yes, another one says no. So by the moment this one says yes, it means that the one who has remained is going to say no. Therefore, we shade this. And when we are shading, this is the way we shade. The way we shade. The way we shade. Shade like that, shade like that, shade like that, shade like that, shade like that. Wow. Now that's that. Now we move to another one. Another one we have 0, 1, we have 2, 1, we have 4, 1. 0, 1 is here. Don't forget, that's 0, 1. Then we have 2, 1. 2, 1 is here. 2, 1 is there. Then we have 4, 1. 4, 1 is here. Wow, that is 4, 1. Now, if that is a 4, 1, we have to ask ourselves, what do we have to do next? is to join those points. By which line? By line y equals to 1. What's the nature of the line? It's broken. Therefore, take note of how we draw a broken line. Now the broken line is drawn like this. The broken line, this is the way we draw the broken line. Broken line is broken, it's broken, it's broken, it's broken. That's that. Now, if it's broken, then we have to ask ourselves that now, what's the name of this line? This line is y equals 1. Now, if y equals 1, what are we interested in? We are interested in y is greater than 1. If y is greater than 1, then here we are. We have this line here. We have numbers that are below and the numbers that are above. Now, if this is 1, is 2 greater than 1 or less than 1? Automatically, 2 is greater than 1. Therefore, this region is the region which is wanted. So we shade that unwanted region, which is this. We are shading that. We are shading that. Then again we have x equals 4. X equals 4. X equals 4 is here. X equals 4 is here. When x equals 4 is here, here we are. Here we are. Therefore, this is x equals 4. X equals 4. Then we need the region which is less than. The region which is less than. The region which is less than automatically is this side. Therefore, it is this side which is also shaded. Now, we have this side which is shaded. We have this side which is shaded. Then the whole of this one is not shaded. But remember, we said that we have some special inequalities. Like where we had that y is greater than 0 and x is greater than 0. Therefore, for this much, we have to shade also this side. We are shading this side. Right? We are shading that side. Wow. Now, what are we remaining with? We are remaining with a feasible region. A feasible region, we say, that that's the region which remains when we've graphed all the inequalities on a single graph. And the region which remains when it is unshaded, that's the feasible region. And when we look at the feasible region, there are some points we have to read off without decimals. Those points are what we call the integral values. Now the integral values we have, remember, we say that the points that lie on a straight line, which is solid, those points have to be considered. Then the points through which two lines cross, when one of them is broken and another one is solid, it has not to be read off. Then all points on broken lines also have not to be read off. Then here we are. The points we have. We have this point. This is 1. 1 is on a broken line. 2, 1 on a broken line. And 3, 1 on a broken line. Therefore, these points on this line have not to be used. Now let us go. We have 1, 2, 1, 2 is there. Right? Then we have 2, 2 is here. That is okay. 2, 2 is there. That's okay. Then we have this one is outside. Therefore, we don't use it. Now, let us go. Here we have 1, 3. 1, 3. That is okay. Right? Then we have 2, 3. 2, 3 is lying exactly onto the line which is solid. Therefore, that point has to be used. Wow! Now that point has to be used. Then we proceed. Then here we have 1, 4. 1, 4 is here. 1, 4 is there. 1, 4 is there. Now, do we have any other point? Do we have any other point? These points here have not to be read. The reason is he had to buy a graph book and then a blacker book. By the moment you read off these points, it means that one of the nature of the blacker books is not being used or is not being bought. Therefore, all points on this line have to be excluded. It only helps us to know the boundary, to determine the feasible region. Now, when it comes to this, let us have the points. The points we have, remember this one is not included, this one is not included, these ones are not included because they are on the block line. Now the points we have this point, we have this point, we have this point, we have this point, we have this point. Remember, we've been asked to determine the least amount of money he can use or the greatest amount of money he can use. Therefore, that one drives us to what we call, drives us to the objective function. The objective function. Now, our objective function is to come from the cost. Our objective function. Objective function. For those ones who may be so confused with these ones, please go back and refer to those previous sessions we had. The objective function, it is referring to the cost. The cost. We say that what's the cost of one blacker book? The cost of one blacker book is 3,000. Therefore, we have 3,000 x plus y plus 2,000 y. 2,000 y. Now, this is the objective function we are going to use. It's going to help us because of being asked to get the maximum amount and the least amount we can use. Remember the other time we talked about the maximum and the minimum of the objective function. Therefore, here we are. We said that when we are looking for the maximum or the minimum of the objective function, what we have to do, we have to use the vertex points. Vertex points. So here, the vertex. Here we have this one. This point cannot be used because it is outside. Therefore, we have this point. It's near the vertex. Also, we have this point. Have you got me right? Also, we have this point. Therefore, that means that the points we can use here, there are three. We can use this point, we can use this point, we can use this point. Now, the points we've seen here, we have x and y. The points we've seen, we have x and y. X and y. Now, if we have x and y, I want to put them here. This is x, this is y. This is x, this is y. Now, here we have this point. Which point is this one? This is 2, 2. We have 2, 2. That's one. Then we have 2, 3. We have 2, 3. 2, 3. We said when we are looking for the maximum and the minimum, we use the vertex points. And the vertex point we've isolated, it is this one, we've seen, this one, and then this one. So for this case, we have 3. Therefore, this point is 2, 2. Then this one is 2, 3. This is 2, then 3. Then another point is 1, 4. 1, 4. 1, 4. Therefore, what we have to do is 1. Here to get the minimum or the maximum, what we are going to do, we are going to substitute in here. For the first one, where there is x, we put there 2. Where there is y, we put there 2. And we get the value. And we get that value. So here we have this. Let us have that. Let us have that. And then let us have that. Okay? When we use 2. When we use 2 here, it's going to be 60,000. 60,000. And when you put here 2, it's going to be 4,000. Therefore, here the amount is going to be 10,000. I'm repeating. When we put the 2 here, it's going to be 2 times the 3, that is 60,000. Plus, when we put the 2 here, it's going to be 2,000 times 2, we get 4,000. And 60,000 plus 4,000, we get 10,000. Right? We go. So now, when we put the 2 again here, it's going to be 60,000. When we put the 3 here, it's also going to be 60,000. It's going to be 60,000. Then the 60,000 plus 60,000, we get 12,000. And when we use 1, when we put 1 here, it's going to be 3,000. Because it's going to be 3,000 times 1. We get 3,000. Plus 2,000 times 4. 2,000 times 4. Therefore, this means that here we have 3,000 plus 80,000. We get 11,000. 11,000. Now, if we get 11,000, we have to ask ourselves, what has been the question? The question has been determine the least or the maximum amount that can be used. Now, let us look here. Here we have 10,000. Have 10,000. How do we get 10,000? If we buy 2 black books and 2 graph books. Then here we have 12,000. How do we come to 12,000? If we buy 2 black books and then 3 graph books. Is it okay? Then how do we also come to 11,000? 11,000 is good. If we buy 1 black book and then 4 graph books. Let us refer back to the scenario. The scenario is demanding for to determine the least amount and then the maximum amount that can be used. Now from here, which one is the least amount? The least amount is 10,000. Therefore, least amount used, least amount equals to 10,000 shillings. 10,000 shillings. And then what about the maximum amount? Maximum amount equals to 12,000 shillings. 12,000 shillings. Therefore, we can use all the 12,000 shillings. If we buy 2 black books and then 3 graph books, or we can use the least amount of 10,000 if we buy 2 black books and 2 graph books. Therefore, that's that. Now, my point of advice is when we have linear programming, we begin with translating English expressions to mathematical inequalities. Then after that, from mathematical inequalities to graphing. Then from graphing to shading. From shading to integral values. From integral values to results. Well, don't forget, if this video has helped you so much, don't forget to subscribe for more videos of the same nature, and also like it. Therefore, what I'm leaving you with is you visit your question banks and then begin of trying as many questions as you can. What I've done today, I've opened the door. When the door is open, it means that you get a lot of hope and then trials. Out of the many trials you get, the more you will get used to that. See you. Don't forget to subscribe for more videos. God bless you.